Okay, you are asked if the here when you update speed, you ask if the object is raw. This is before you click. It is a raw speed, and you assign the bullet raw speed. And if it is not raw, you assign the push speed. These speeds are changed by using a toggle bullet speed static method for our game configuration. And here we assign different raw and push speeds. We have a slow speeds and fast speeds, and when we will do that, we emit to a on bullet speed toggle signal. So every bullet in our scene that is going to be listening to this signal event is going to update its speed. And here, as we are inside a static method, we don't have an instance for a dispatcher to send, so we can send a string with the name of this class. So when we are debugging our communication system, we can know that this method was called by game config. I have to mention something important, that here, for example, um, we connect we connect to these signal events on awake, and we also need to disconnect from those signals when this game manager is destroyed. So here we disconnect. When we disconnect, we don't need to pass the callback, because it makes no sense if that we connect various callbacks to the same signal event. So it is going to be only one. So we only need to pass the listener that was this class. So we pass this. So now I'm going to explain some other things of this code so you understand what's going on. Here we are setting that we print all signal actions. So we have in the console, as you could see in the first video, that everything was printed. Here we are creating the game objects that are going to contain boxes, drops, and our click effects. So we create those containers with the names we have in constant strings here, and we assign a reference distance from camera. Here in our inspector, we assign, for example, no, sorry, yes, we assign our vertical canon as a reference. So we use the depth value, the C value. So we use that reference position C value, and we subtract that using our camera position in C, and we get our distance from camera. So when we click, we have a proper world position for other things to work. So here in our update function, we check if left mouse was clicked. Here we determine a mouse world position. We use this method using our game camera, that we have a reference here. We have a reference to our main camera, and we use the screen to world point. We pass the mouse position X and Y, and we use our distance in C for the C value, and we return that. So as we get the mouse world position, here we emit the signal event using emit params. as you can see here, if I do this, I know what do I have to pass to this event. I have to pass the dispatcher, that is this instance, and I have to pass the position where I want the where the mouse click is being done. So I pass the mouse world position, and then here I'm going to create the special effect, the particle system. So I instantiate my click FX prefab in that position with a neutral rotation. Here I assign a parent the click FX container. So our click effects are going to be children of that parent, and we have our scene organized. Then if I have not clicked left mouse button, I check if I have pressed right my mouse button. If I've done that, I use this create bullet method that I presented earlier. We use the get mouse world position again to get our position, um, and here, as I said earlier, we pass a vector 0, so the default direction for drops and box is used instead. And here I check if I've pressed the space bar, and I call the toggle bullet speed method from game config that is static and that I presented earlier. Let's see what else is here to show you and explain. Well, I'm done with this. Well, in the case of box, it is very similar to, it's the same as drop, only that we use well, this method is different in box and drop. Let me show you here in our drop code. When we handle the mouse left click event, here we calculate the direction away from the click world position here, and we put the Z direction into 0 because we don't want our bullet to travel on the Z axis. Here we set that the bullet is no longer raw, and we update the speed. In the case of drops, I mean in the case of boxes, here the calculus is different, is the opposite, and the other things are the same. Okay, I think the last thing I need to explain is how our canon works. No, I still haven't shown you the bullet code. This is the base class for drops and boxes. We have a speed, direction, we have a transform that we pick up once. Here, well, we connect to those events, we already saw that. We update our speed when we start. Here we calculate the delta position based on speed and the time between frames, and using our direction, and we add that to our position. When we destroy, we disconnect from the signal events we connected when the instance is created. Here, when we enter the trigger, this is with the walls. This object gets destroyed. Here, when we receive the onboard speed toggle event, we update the speed. I think I already mentioned this. Here we have the set direction method, just to check our direction.